Alright, today I'm going to talk about linear programming. On the linear programming, you're going to do these two problems with me. I'm not actually going to have you turn anything in. The stuff with this stuff, it's same thing as systems of inequalities, but the only difference is that you have more than two, which gives us a contained region. So if you remember back to when you were in the desert, it would be like there was fires all around you and there was only a certain area in the middle where you were safe and there was no way to escape. If you remember when we were in the desert, right, you could have escaped over here, you could have escaped over here. But what we're going to do today is we're going to put another fire here and another fire here. So essentially there's a contained region that you're inside of that you can't escape from. So that's what we're kind of doing here. So we're going to graph them out just the same. So I'm going to start right here. I'm going to ignore this top part. I'll talk about that in a second. I'll talk about that in 1 second. And I'm going to graph this out. So I'm going to start at 4. I have a slope of -3/4, which means I go up 3 and over 1. It's or equals to, so it's going to get a solid line. Now on these ones, they're a little bit different. I do need really good lines. So I'm going to actually put another point and just make sure that I connect all 3 of my points. Okay. Now it's less than, so I'm going to shade below it, which means everything over here. Now I'm going to do the next one. Has a y-intercept of -3 and a slope of 2. I'm going to make another point just to make sure. Connect these. And this one's dashed. Now when you deal with linear programming in the book and in real life, you'll actually never see ones that are dashed line. They'll all be solid lines, but for the time being, I'm just going to leave that. Okay. And then this one is greater than, so I'm going to shade above it. So that means that now we're contained to this region right here. We lost this little part over here. Then it tells me x is less than or equal to 7. So I'm going to go to 7. And that's going to be a vertical line. And it's less than, so it's going to be shaded this way, which doesn't really change anything that I had. If I continued my lines on, it would eventually, it's not even ever going to touch it, so don't worry about it. And then greater than or equal to -1, which is going to be right here, another vertical line. And it's greater than or equal to, which means the only part that is a solution to every line is right inside of here. In this little triangle that I have right here. So looking in on this little triangle, we want to look at the vertices. The vertices are the points where the lines touch. So if I'm looking at this little triangle, let me get a darker pen. If I'm looking at this little triangle, the vertices are where they touch. So this point, and this point. So I need to label what these points are actually. This one's going to be -1, 5. This one's going to be -1, -5. And this one's going to be 3, -1. So my 3 vertices are -1, 5, 3, -1, and -1, -5. Now, going back to the original rule that I had, the original rule that I have right here that I put the star next to, this is like my containment region, and they will ask me for a minimum or a maximum using this equation. The minimum is the lowest value when I plug in my vertices, and the maximum is the highest value. So I need to use this equation right here and plug in each of the 3 different vertices that I just got. So I'm going to do P equals 2 times -1 plus 3 times 5, which is -2 plus 15, which is 13. Now I'm going to do P equals 2 times 3 plus 3 times -1 equals 6 plus -3 equals 3. And then the last one, P equals 2 times -1 plus 3 times -5, -2 minus 15. So P equals -17. So if it's looking for the maximum, this is the maximum solution. The maximum value that gave me that was -1, 5. Minimum, this is the minimum solution. the minimum value that gave me that was -1, -5. So those are the maximums and minimums. Okay, so now I'm going to do that for this other one that I have right here. I'm going to start at 1, and then I have a slope of 4, which brings me up 4 over 1. Connect those guys. It tells me it's greater than that, which means I'm shading to this side. The next one also has a y-intercept of 1, but it has a slope of -4, so I'm going to go up 4 over 1, which means, got that guy. Both of these are actually dashed. I'm going to change them so that I didn't do it wrong. This one says less than, so I'm going to shade below, which means I'm over here. Tells me greater than or equal to 7. Y is greater than or equal to 7. Which is going to be a horizontal line right here and shading above. So now I'm only in this region over here. And less than 10. Which means my final solution is right in here. And I need to find the vertices. Vertices on this guy are going to be right here, and I probably should have put an x on there, so I'm going to say x is greater than or equal to -12, which is going to put this line right here, so I have 2 vertices there as well. It has to be a contained region, so now I have a contained region. So now I'm going to put all of my points, all of my vertices. This one's at -12. 1, 2, 3, 4, 5, 6, 7. This one's at -12, 10. This one's at -2, 7. And this one's at looks like -2.5, 10. Remember, we're going to plug those values into this rule right here in order to see which ones are minimum and which ones are maximum. So we're going to plug in each of those values. So we're going to do P equals P equals 3 times -12 minus 17 times 10. -36 minus 170, -206. Then we're going to do P equals 3 times -12 minus 17 times 7, -36 minus 119, -155. P equals 3 times -2.5 minus 17 times 10, -7.5 minus 170. P equals -177.5, which we don't want that, so we're going to actually turn it into a fraction over 2. -354 over 2. And then the last one, P equals 3 times -2 minus 17 times 7, -6 minus 119, -125. So if I'm looking for the minimum is going to be this guy right here, -206. If I'm looking for the maximum is going to be this guy right here, -125. And that's it for these guys. We'll do a bunch of these in class. If you have questions, bring them with you.